Greetings and welcome, friends. Mr. Wadi here. We're talking about vertex form of parabolas. Yeah, we're going to look at a couple of word problems maybe. So here we go. A portion of a roller coaster track is in the shape of a parabola. Write and graph a quadratic function that models this portion of the roller coaster with a maximum height of 90 feet. So that sounds like K. Represented by a vertex. Oh, they gave us H and K. How generous of them. I don't know. I don't know enough about roller coaster. Although I have heard that the Vomit Comet, when you go on a plane that can simulate 0G gravity, that it travels up and down at high altitudes in parabolic curve, resulting in the sensation of no gravity because it's following this parabolic path the whole time. Yeah, so here's 1 point. This is our H comma K, our vertex, so 25 comma 90. Yes. We're like, I doubt it. We don't have a lot of time left in the semester. So here's the starting information. We're also starting with the curve on the track at 0. And so with the equation of a parabola, like I said, we were talking about vertex form. And it's going to be y equals a parentheses x minus h all squared plus k. And I'm going to plug in what I know and solve for what I don't. So I know the h and k, and I know a particular combination of x and y, and I don't yet know a. So a is going to be the thing that I'm trying to find. So let's plug in what we know and solve for what we don't. So y is 0, a is unknown, x is 50, h is 25, plus k is 90. Right, so let's see if we can simplify and solve for a. So 50 minus 25 is 25. 25 squared. I feel like I should know that one. What? Oh, man, why don't I? 625. Not even close, Mr. Wadi. So 625 A plus 90 is equal to 0. So to solve for A, we'll subtract 90 from both sides. And so I'll have negative 90 equals 625A. And then A is being multiplied by 625. So the way to undo that is on both sides, yeah. And so I end up getting A equals, oh, that's reducible. Man. 5. Let's see. Let's actually start canceling that out. 10 doesn't go into both of those. 5 goes into both of them 18 times. Yeah, so 5 goes into 90 18 times, and 5 goes into 625. It's going to be what? 125 times, I think. So I believe it reduces to negative 18 125ths. Let's see, there we go. Like so. So now I can write my equation where I'm not going to include the x and y in it. I want to leave the y and the x generic, so it represents all combinations of x and y that make the equation true. So it's going to be y equals negative 18 125ths, x minus 25 all squared plus 90 will represent the equation of this parabola. And it's going to look something like this, right? But let's actually, I missed it. There we go. That's close enough. But let me pull this up in Desmos just to verify, to show you guys that we can actually, based on these points, plot those points and find that our equation was correct. So here's negative 2590. Where is it actually, guys? Where is it? Oh, I got to zoom out, right? Aha, exactly. There we go. All right, there it is. There's yeah, that's what it's supposed to be. And then let's see, 50, 0 was another point. So 50 comma 0. Well, it needs me to put it in parentheses. It's all like, I don't know what you're talking about. Ah! Right, okay, so there we go. Also, Desmos trick, if I click on the Y and then mouse wheel, it'll zoom just the X-axis. So if I want to stretch my X-axis window like that, I can. And then if I click on the X and zoom out with the mouse wheel, it'll change just the Y scale. So let's see, the equation was Y equals negative 18 125th, get out of the denominator, X minus 25, all squared, plus 90. Bam! You sunk my battleship. Look at that, I hit both of those points perfectly. Chop, chop. Also, tell you what, I can change this into projector mode. There, now we can see it a little bit more clearly. Ooh, lovely, lovely. Let's see, I've only been talking for a few minutes here. 6 minutes. Tell you what, your lucky day is today. I'm going to go over the other problem, too. Wow, what? No, not right now. So let's see, let's interpret this. So a flare, whoa, is launched from a boat, right, and travels a parabolic path until reaching the water. Write and graph a quadratic function that models the path of the flare with a maximum height of 300 meters occurring at this. So there's our H and K. So, 59, 300. So that's right about there. This X scale is counting by 10, so 59 is going to be right up on the edge there. And 119 is going to be my X and Y. So 110, 20, backwards 1 is right there. All right, so those are our points so far. And like I said, we're trying to graph this in vertex form, which I think is like the best form. We're going to talk about a different form today, foreshadowing. But I think that this is the best and easiest way to graph parabolas. So 0, plug it in for Y. A, I don't know what A is. 119 plugged in for X, minus 59 for H, squared for squared, and 300 for K. So let's simplify this using PEMDAS and then solve it using algebra. 119 minus 59, is that 60, I believe? So this is going to be 3,600A plus, nope, plus 300. Man, come on, Mr. Waddy. With the writing, do the writing thing. I like it. Man, why can't I complete a 0 here? So I'll have negative 300 equals 3,600A, and then what do I do to solve for A? I like it. So to cancel this one's got 2 zeros and 2 zeros, so that's like I divided top and bottom by 100. 3 goes into 3 once and into 36 12 times. So it looks like A is going to equal negative 1/12, which is, oh, it's in meters. No, yeah. Yeah, that's weird. This is actually not the path that a flare would take on planet Earth. That would be weird. What if you like woke up and you were on like a like rescue boat and you're out in the middle of the water and then like you're like, we got to get out of here. I don't even know how I got here. And then you shoot a flare and then like one of the guys knows the math and he does like the parabola of the path of the flare and then he's like, wait a minute, guys, we're not on Earth. The gravity is all wrong. Something's wrong with the gravity. We shot a flare and we're in the middle of the ocean, but we are not on planet Earth. And then like that would be the end of the movie. And then like it'd be crazy. It'd zoom out and they're on a completely different planet and it'd be awesome. So no, it doesn't. So let's see. Yeah, they're just on a different planet, or the, you know, Saturn. Is it what Saturn has the moon Titan that has frozen water on it? So maybe if Titan was hit by a rogue asteroid and knocked it, or was gravitationally pulled by an asteroid or another planet that pulled it close to the sun, heated up that water, turned it into liquid. It'd be interesting. Well, it would take a much longer time for it to get to another sun. Also, bad news, everyone. Milky Way galaxy is going to collide with Andromeda in a few billion years. But they actually predict that there might be 0 collisions between suns or planets, even though like there will just be like so many objects colliding with one another. Also, Mass Effect Andromeda coming out in March of this year. So, I don't think so. Let's see, 59, 300. All right, I'm gonna have to zoom this out a bit more. There we go. Yeah, I don't know. Drinkable is their concern, I believe. So this was 300 high. So guys, here's our graph. There's the path of the flare. Tell you what, watch, I can even make the flare's color, orange. And you're going to want to time your flare shot when hopefully a plane or another boat are going by, and then they'd be able to track your information. Because of gravity. Flares don't float in the sky. Gravity. Not a flare. Not a flare. A flare has a long burn time. That's why also, like, even just at an accident on the side of the road, they might set up flares just to kind of warn traffic coming of like, oh, look out. Right, but no, even a flare shot from a gun, it's just going to leave a trail the whole time. And technically, if it didn't land in water, it would probably burn out for a while here. Unless, do they design the fuel in a flare gun shell to last only as long as the flare would be in the air? So then you're actually able to get a higher shot because it's not carrying a whole bunch of extra burn fuel. Anyways, thanks for watching, Internet friends. Have a great day. Bye-bye.